Hey guys, I'm going to do another example of this topic of using statistical measures to compare populations. Really what they're really talking about here is you guys know how to compare box plots and box and whisker plots by simply looking at it, comparing the average, the median. But here we're really focused on what we call the MAD, the mean absolute deviation. Okay? That's really what we're doing here in this example. That's really what this chapter is mostly about. So the first thing you want to do is you want to find out what the mean is. What is the mean? Okay, remember, mean is the average. Okay, to find the average of any group of numbers, such as this class right here, you have to take all the numbers and add them up completely, and then divide by how many numbers you have. So let me do that here. It's going to seem like it's a lot of work for something like this. It is, quite honestly, it's a lot of work, but it's not difficult. It's just tedious. There's a lot of little work that you have to do to get the actual answer that you're looking for. All right, so what I'm going to do is I'm going to list out all these numbers. And the reason why I'm doing that is because I got to use them again a little bit later. Okay, so I wrote them all out. That's just for class 1 students. We're going to add them all up, and we're going to divide by how many we have. We're going to do the same thing over here for this class. So I've got 11, 14, 11, 13, 6, 7, 8, 6, 8, 13, 8, 15, 13, 17, 5. This is most helpful when you have a calculator. I'm going to use my iPhone to do the division part, but I'm not going to use the add. I don't think I need it to add. So let's go and add it. All right. So 12 plus, this is 7, so 12 plus 7 is 19. 19 plus 1 is 20. 20 plus 10 is 30. 35, 45. 45, this is 6 plus 8 is 14, so 45 plus 14 is 59. 59 plus this 9 is going to be 68. 68 plus 8, 76. 76 plus 6, 82. 82 plus 8 is 90. So the total is going to be 90. Then I'm just going to divide 90. Divide that by, how many numbers we got? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So divide by 15. All right, so the average is 6. So class average or class mean, class 1's mean equals 6. Okay, and that's important to know. Okay, it's going to help you figure out your MAD here in a second. Okay, we won't need this number anymore, so it's not necessary. So I'll just kind of mark it out because we don't really need it anymore. Okay, let's do the same thing for this one. So we're going to add this and divide by how many we have. All right, 11 plus 14 is 25. 25 plus 11 is 36. 36 and 13, 49. 49 plus 6, 55. 55, this is 15, so that's 70. 70 plus 14, here, this is 14, 84. 84 plus 21 is 105. 105 plus 15, 120. 120 plus 13, 133. 133 plus 17, 150. 150 plus 15, 165. All right, I think. All right, so that's 165. And then we divide that by how many we have. Okay, so 165 divide by 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Divide by 15 equals 11. So the mean, so class 2's mean equals 11. Okay, and again, that's important as well. We don't really need this no more. So here's what we do. So we got to take the average for each class, and we got to subtract that number, which in this case is 6 for this first class, and it's 11 for the second class. What we're going to do is we're going to subtract that from each number in the group. So for example, so this first person in class 1 ran 12 miles, okay? That means he ran 6 miles over average, okay? Let me see if I can do the focus a little bit better. My focus is a little bit off, I just realized that. So it might help a little bit. Alright, it's a little better, okay. For the second person, this second person only ran 1 mile, okay? He is below average, right? He's 5 miles below average. So 1 minus 6 is 5. Now, you might be thinking, wait a minute, that's negative 5, Mr. Freeland. 1 minus 6 is negative 5. That's true. What you'll notice is, a lot of times what they'll do is they'll put absolute value brackets around the negative, the minus, the subtraction problems, and so your answer will always end up being positive. So even though technically it's negative, they just want to know what the value is. They don't care that it becomes negative or positive. They just want to know how much off is it from the average. So what you're doing is basically just subtracting 6 from each one, because again, we're comparing each number with the average. How far are they off from the average? And you're going to find out for each one. So you've got a lot of subtraction problems right here. And again, this is the tedious part. Not hard work, it's just tedious because there's a lot to do. So 6 minus 6, 0. 10 minus 6 is 4. 1 minus 6 is negative 5, but again, we're looking at for absolute value. So it's just 5. 2 minus 6 is negative 4, positive 4. 3 minus 6 is 3. 10 minus 6 is 4. 3, 2, and basically you see where I'm getting at. So all these end up here. Okay, so that's how much they deviate. That's where that word comes from, deviate. So it deviates this much. So again, first person that ran 12 miles, he ran 6 miles extra. Second person that ran, he ran 5 miles less than the average. This person ran the average. This person 4 miles above average. So what you got to do now is you got to add these all up and divide by how many you have. So same thing that we did earlier to get to 90 and divide by to get to 6. Now we got to add all these up and divide by how many we have. So this is 11, 15, 20, 24, 27, 31. 31 and 5 is 36. 36 plus 6 is 42, 44, 46. And then you take 46 and you divide it by how many we have. Now, I completely forgot how many students I had in that example, so I'm going to have to count again. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 46 divided by 15 equals, okay, yeah, it's close to about 3.1. So we're going to say the math on this one is around 3.1. Okay, roughly. Now we're going to do the same thing for this one, except we're not going to subtract 6 from each one. We're going to subtract 11. We're going to find out what's the difference between this number and 11 from each one, because this is a different class. They had a different average, a different mean. So you do the same thing here. And I'm putting the absolute value brackets over there. This might be a little confusing because it's got the same color. Let me switch to different colors here. I do not want to cause any confusion on this one, because it can get very confusing. There's just a lot going on. Let me switch to brown here. There we go. It's a little better. That 11 is really... It'd be nice if it was a different number. Okay, so these absolute value brackets, again, they don't really do anything. All they do is just basically say whatever the answer is going to be, the outcome's always going to be positive. So, all right. So we're going to subtract 11 from each one. We're going to find out what the value is for each one. So the first person that ran 11 miles. Well, the average was 11, so they ran the average. So there was no difference. There was no deviation there. This one, 3 miles extra. This one ran the average. This one ran 2 miles extra. This person ran 5 miles below average. This person, 4 miles below average. This person here, 3 miles below, 5 miles below, 3 miles below, 2 miles above, 3 miles below, 4 miles above, 2 miles above, 6 miles above, and then 4 miles above. And then what you're going to do, take all your deviations, all your differences between each person and the average, right? Find out what the total is, and we're going to divide that by how many we have. We're going to find out the average deviation, right? The average. So 0 plus 3 is 3, 3 plus 0 is 3, 3 plus 2 is 5, 5 plus 5 is 10, 14, 17, 22, 25, 27, 30, 34, 36, 42, 46. Wow, same number, same total. Interesting. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Divide that by 15, and guess what? You get the same exact math. And that's not typical. Usually, most of the time, your math's going to be different for both ones. It just happens to be the same answer. Odd. Because they're different numbers. So that's basically it. So the average was 6 for class 1. The average or mean for class 2 was 11. The math for both ones was 3.1. 3.1. And then sometimes you're going to get another question. You might see this again. Where it says, what's the difference of means? The difference of means is about blank times the mean absolute deviation. So what's asking is basically saying, hey, how much bigger is 6 more than 3.1? That's all it's saying. How much bigger is 11 greater than 3.1? And so basically you're just doing a division problem. Okay? So basically it'd just be 6 divided by 3.1, and you should get something like this. So I think that's what it's asking. I could be wrong. I know the difference. Oh, you know what? Actually, I got it wrong. The difference between 6 and 11 is 5. That's where they get that from. And then they did 5 divided by 3.1. That's where it is. So it's 1.61. 1.61. So that's about what it's going to be. So that's going to be the difference of means. It's going to be 1.61. But really what you're looking at, and that's for another type of question, but really what you're looking at is you're looking for the mean, 6 and 11, 6 for the first group, 11 for the second group. You find the differences for each one from its own average, right? Because it has a different average for each group. Add that up and divide by how much you have, and you'll get your MAD. Okay? This is MAD work. This is a lot of work for one question. But you're not going to see this very often. You're going to do this maybe two more times in your homework, maybe, and that's it. Okay, everything else is based off of that. All your numbers, all your answers are going to be based off of what you did here. So hopefully that helps. Sorry guys, I know it's kind of a beast. It is a lot of work here involved, but I promise you it will get easier after this. We're not going to be staying on this lesson for too much longer than we have to. God bless. Talk to you guys later. Bye-bye.